All right, everyone, I'm going to go ahead and get us started. There's going to be a few more people that log on, or I hope so, as the day goes on. So thankfully, we've had some people join us, and we're going to get started with our last webinar of this year. So just so everybody knows, Colorado State is an equal opportunity access and non-discrimination university. So if you ever have any issues accessing any of my content, especially this webinar, please let me know, or if anyone who you know who would like to actually access this video and are having issues, let me know. So before we get started, let's talk about a little bit of Zoom etiquette. I love it if you guys can turn on your cameras, mostly because that turns this into less of a radio show and more of an interactive experience. But we do understand that sometimes our internet here in the Grand Valley and across the Colorado State is not always the best. So if you have to keep it off for bandwidth, I definitely understand. Please keep your mics off until the very end. This is just to make sure we don't have any feedback issues or any background sound issues. If you have a mic, you are very welcome to use it at the end to ask your question verbally instead of having to type it out. I know sometimes it's hard to remember your question all the way to the end, so feel free to use the chat box that's in the right-hand bottom corner of your Zoom window. I've just sent a little thing through that right now, so you should have a little notation that pops up. Feel free to drop your questions in there all throughout the webinar, and we will ask them at the end. Unless it's something really, really pressing, I won't be breaking up the presentation just to ask a question. So let's introduce today's speaker. We have Dr. Achala from OSU, or Oregon State University, not the OSU. She works down in the Southern Oregon Research Extension Center in Oregon. They have multiple different research stations across the state that all work in vines, but she is an associate professor of plant pathology, so she works on both trees and vines. And red blotch is actually just one of the things that she is focusing on right now. And I'm very happy that she's able to talk to us about it, because Oregon has kind of been pioneering a lot of the work with red blotch. So I hope that she can spread more information to us here in Colorado today. So without further ado, I'm going to stop sharing my screen and let Dr. Achala take over. And I will also mute myself.
All right, so can you all hear me? Perfect. Hey, yeah, good afternoon all. Yeah, it's great to be here today with you and talk about Grapevine red blotch virus. So like Charlotte mentioned, I'm here at the station for 7 years, and I work on the areas of tree fruit diseases and grapevine diseases. So I work on all fungal, bacterial, viral disease problems on these two crops. On grapevines, I work on grapevine trunk disease and grapevine red blotch virus. So those two are the main projects that I have ongoing right now. So I'm glad to bring some of the results from our 6 years of study on grapevine red blotch disease. Okay. So in my talk today, I will be primarily focusing on sampling for the red blotch virus, how to identify it, how to diagnose, and also the epidemiology, or more like how it spreads over time in a vineyard if you first find it. So all those based on the Southern Oregon vineyard studies. Okay, yeah, let's begin with the distribution of red blotch disease in United States. I hope that you now know a lot about grapevine red blotch virus, but it is fairly a new disease. And we say it new disease because it was recently discovered. It was first discovered in California in 2008, and it was more like an accidental discovery than, like someone was looking for it. So when they were thinking it was a leafroll virus, and when it came negative, then yeah, testing for the more studying for the red blotch started, and that's how it got discovered in 2008. It's a virus caused by grapevine red blotch virus within the group Geminiviridae. And within the United States, the red dots represent the area where it has been reported. Now that I was just talking with Charlotte, she mentioned that it was also reported in Colorado, but yeah, I missed to have that star in Colorado State. So if it is published, I'm not sure, then okay, yeah, probably that's why. So this information is based on the publicly available data. And now it has been reported from countries other than just United States. It has been reported from Canada, Mexico, Argentina, India, and South Korea. So yeah, it's an increasing trend that this virus has been reported in several different countries as well. So why is this virus important? What it does to our grapevines? So mostly the losses due to the virus is associated with the reduction of the fruit quality. It doesn't do that much to the yield, but the fruit itself is the quality of the fruit gets reduced. And also it delays the ripening. And we have also seen uneven ripening of the fruit, which is, like difficult during harvesting if the fruit, the berries ripen unevenly during the harvest time. And the reduction of the fruit quality comes from a reduction in the total soluble solids. There is a reduction in sugar. So yeah, up to 4-degree Brix has been reported to be caused by the virus. And also on the red fruited cultivars, it reduced the anthocyanin of the berry skin. So, it also alters the color of the wine. So there is like a direct effect on the wine quality as well. And depending on what kind of vineyard you have, either the younger vineyard or the older vineyard that you get a lot of money from, the estimated cost of the grapevine red blotch disease range from $2,000 to $68,000 per hectare. So if it's like old and a vineyard that produces a lot of quality wines, then the cost of this disease may go up to $68,000 per hectare. So how does it spread? So both short and long distance spread have been reported for this virus. It is graft transmissible, so meaning that if we have a scion or rootstock infected, then chances are that we are transferring the virus from infected material to the new planting material that we are developing. Also a rootstock and the traits associated with the shipment of infected planting material. So that's more like a long-term spread of the virus. So if you are planting a new vineyard and buying the new vines, it is very important to check the status of the virus. In many states, it is now a regulatory pathogen. So the nurseries are required to have the certification status. So if you buy from the certified nurseries, most of the time they will have the status of grapevine red blotch virus on their certification. So it is very important that you check your material, because yeah, that's the main way to get it long distance spread. And also, once it is established in the vineyard, there are insect vectors. So since this is a virus disease, it is vectored by three-cornered alfalfa hopper. And yeah, there is an ongoing work on finding other vectors as well. But so far, this is one of the vectors that has been confirmed to transmit the virus from a vine to vine. Yeah, so that's the virus, that's the vector, and we can see girdling on the vines if the vector is present in the vineyard. So that's one of the signs to look for if there are any vector activities or not. So the current management recommendation for this disease is planting the vines produced from virus-tested scion and rootstock source material. There is no cure for a virus-infected vine And there is also no chemicals known to control the virus. So it is very important that like we are aware and then do not let this virus introduced in a vineyard. There is no cure. Even though the possible insect vectors have been considered for this virus spread within a vineyard, insecticide applications are not yet recommended. So yeah, first we need to confirm what really is the vector, and then there has not been a lot of work done on identifying the insecticide that would be effective to control these vectors. And also we do not just want to go rampant and apply the insecticide, because we might be disturbing the natural enemies of the real vector. So we do not want to do that as well. Vine health itself plays an important role in combating plant pathogens and insect pests. So we have seen in our past experiment that keeping the vine healthy, either by irrigation or nutrient or whatever source, that helps to combat the virus symptoms. Mostly we have seen the positive effect of keeping the vine less stressed. That's the main point. So we have seen that if the vines go under stress condition, it shows more symptoms of the virus. So yeah, it's very important that we keep vine healthy if we were to combat this disease. And in an established vineyards, if the grapevine red blotch virus is suspected, then the best idea is to get it tested by the commercial lab. So there are several commercial labs in the West Coast. I'm not sure if there is any available in the Colorado. Maybe Charlotte have information on that. But yeah, it's better to have it tested if you suspect of the virus in your vineyard. And if you find a positive vine, then yeah, it's better that you rogue that plant. You take that vine out to limit the spread within the vineyard. So that is all the current recommendation for management. So since one of the major thing that we can do after the virus has established in a vineyard is monitoring regularly for the virus. And if it is suspected, then it needs to be tested. And then if it comes positive, then remove the vines. So that's one of the active practice that we can implement to minimize the spread of this virus. So since finding the infected vine seems very important for minimizing the spread of this virus. Yeah, there are several confusions regarding the sampling for increased accuracy of GRVV diagnosis. So yeah, we started the same way, like when we started seeing red blotch virus in our vineyards, it was the same confusion going around, like yeah, the vine turns red for so many different reasons, but how can I tell it's a Grapevine red blotch virus? And how can I tell if it's not the other viruses? So yeah, we have come far with the diagnosis and like identifying the vines and such. So yeah, I'm happy to share some of our results today here. Okay, if we are trained, we can identify the disease based on the symptoms, but I will come later because it could be really confusing. So to understand the red blotch virus symptoms on red-fruited cultivars, it's kind of apparent in the red-fruited cultivars because it just shows like these red blotches on the leaves. So at the beginning, we start seeing these blotches around horizon. So that's the time we would want to go out and see if there are any infection due to this virus. So it starts with this. Can you see my arrow here? Okay, good. So these blotches, like reddish kind of blotches, start to appear on the basal leaves. That's during veraison. So that's the first indication of the virus. And once season progress, these blotches start to become more prominent and they kind of start to coalesce, like they combine and they kind of start to make these long stripes of redness between the veins. And around harvest time, as we progress during the season, the whole vine can to turn red, and the leaves will turn the stripes of red in between the veins. That's how it happens in the red-fruited cultivar. Where is my... Okay. And this is how it looks in white-fruited cultivars. So it's a little confusing on white-fruited cultivars, but if we look closely, it seems like we can also identify the symptoms on white-fruited cultivars. So it starts the same way, but instead of redness, it starts to become yellowish. It starts with yellowish blotches between the veins in white-fruited cultivars because they do not have anthocyanin, so they won't make red blotches. They would make more like yellowish blotches in between. And as the season progresses, that yellow turns necrotic, and then we would see these necrotic, like lines in between the veins on white-fruited cultivars. So that's how typical symptoms of grapevine look like. But all these symptoms, like unless your eyes are really trained, it's very difficult to separate between all other different symptoms that grapevine shows, and that could be because of the other virus, grapevine leaf roll virus. And just talking with Charlotte, she mentioned that leaf roll is a problem, and it could be confusing with the red blotch virus. One of the major differences between these two is with the leaf roll virus, the leaf kind of rolls downward, but you won't see that in the red blotch virus. The redness is pretty much the same, but if the infection is really severe, then the curling is severe on the leaf roll disease situation. And the nutrient deficiencies, like all kind of nutrient deficiency, potassium, magnesium seem to turn the leaves red. So it's kind of difficult, but most of the times the nutrient deficiency redness seem to stay around the margin. It does not go, it does not come like a blotch. It's more like a straight line of the redness starting from the margin. And we sometimes get confused with the spider mite too, because it's more like a dots on the red-fruited cultivars, and it's very distributed throughout the leaf, the dots, but can be confusing with the red blotch symptoms. So we say that, just test, like if you are confused, don't guess. The symptoms can be really confusing if you are seeing the red blotch for the first time. So just if you suspect that could be a red blotch, just test it out. And so this is a very interesting, and I find it very interesting while talking about the red blotch disease. And so this comes from one of the presentations that one of our vineyard manager made when we had the first issues of the red blotch virus in Southern Oregon. So this is exactly how it happens, so you suspect for the virus, you send it out for the testing, and when it comes out, when the result comes out, then when you are thinking, okay, there is no red blotch, then that comes out positive, and when you think, okay, that may be red blotch, and that may come out negative in your test. So it can be confusing, and it was back in 2017 that this presentation was made, and I was newly starting and being a pathologist. My head was going like, why is it why the diagnosis is not so confirmatory when it comes to the red blotch virus. And so there can be several reasons, if you are not seeing like a higher accuracy of what's going on your vineyard, there could be several reasons, and it could be because of the sampling method. What part of the vine you are taking samples to send for the testing? Are you combining all, like multiple vines in a vineyard, or are you taking sample only from the suspected vine, or what you are doing? So that matters. Sample tissue. So where are you getting your samples from? Are you getting from the older vines, or are you getting from the top of the canopy, or are you just mixing all over the place? That could be one of the reasons as well. And phenology. So what stage of the grapevines you are taking samples from? Are you taking early on when the leaves just come out, or are you taking during the veraison, or are you taking during the dormancy, or are you taking during the harvest? So all those things seem to matter when it comes to increasing the accuracy of virus detection, because it's more like the concentration of the virus, and we found that the concentration of virus in the vines increases as the vine progress during the season. So it could be the virus titer, and it could also be the detection methods, So when you are sending your sample to the lab, it's a good practice to ask questions like, what kind of method do they use? Do they use PCR, qPCR, ELISA, or what kind of methods are they using for the detection? And yeah, sometimes it could be not you, it could be on the lab side as well, like there may be chances of sample contamination. So that might result in false positive or false negatives. So that could be an issue too. But like most of the time when we process our samples, we are very careful with the contamination. So we do not mix the samples. We follow the proper sanitation protocol and things like that. So it is very important that the sample did not get contaminated. And sometimes, like infection might have just occurred after the test. So you collect your samples and then send for testing. It comes negative, but next season you see symptom on that same vine that you had tested negative the earlier season. So if there are vectors, chances are that, that vine got infected after you tested your vine. So there could be several different possibilities why we do not get accurate assessment of what's going on. So yeah, given those issues, we set some experiments to test, like how all these factors affect the accuracy of the detection. So we looked at different sampling methods, we sampled different tissues, we collected samples at different stages, and also we use different detection methods. So for the different stages, so we selected 20 virus positive vines and 20 virus negative vines. So these were confirmed from the earlier years. So we knew that 20 were positive vines, 20 were negative vines from the earlier years testing. And following that year, we collected samples from fruit site. We collected samples from veraison. We collected samples from harvest and also from the dormant cans. And then we for each of those stages, we collected samples from base of the canopy, middle of the canopy, top of the canopy every time. And then we used 4 different methods. So LAMP, it's a relatively new method. I'm not sure if you are familiar with this technology, but this is less expensive. And like there will be initial cost of setting it up, but the growers can use LAMP by themselves if they are properly trained, and you can do your own test using LAMP. It's molecular based test, and yeah, there are several companies now developing LAMP assays to be available for the growers or the managers. And another is conventional PCR and also qPCR. Those are the tests that most of the commercial labs do, and also symptoms based. So how much can we rely on the symptoms? We looked at that as well. And yeah, from the growers here who is using lamp versus the commercial lab, they say that with lamp, in the long term, it would cost like $2 per sample to do the test. Whereas if you are sending to the commercial lab, it's around $30 per sample to test the red blotch virus. So there is this big difference. So this is the result that we found at fruit state. So you remember we were testing samples from the base of the canopy, middle of the canopy, and the top of the canopy. So from those 20 vines that we knew were positive, while using the different methods, we found that during fruit stage from the basal canopy, when we're using PCR and qPCR, we're finding all, like the 20 vines were tested positive using those methods. When we were using middle of the canopy, both PCR and qPCR results were less. And when we were using the samples from top of the canopy, it went even down. So it was able to detect only 25 to 50% of the positive vines being positive, even using the most sensitive assays like PCR and qPCR. At fruit set, lamp really did not do good. There were like more than 50% of the false negatives coming from lamp assay, and fruit set, there were no symptoms. So there is no way of relying on the symptoms-based assay during fruit set. At Verizon, so everything kind of shifted. So again, PCR, qPCR, were still the sensitive assay from the base of the canopy, we're detecting 100%, and the number went up at Verizon if we're getting the middle samples, and also for the apical samples. Lamp test was still, there were still some false negatives. And symptoms started there. So at the basal of the canopy, about 25% of the positive vines were showing symptoms. And still at the top of the canopy, none of the positive samples were still showing symptoms. So the first to see symptoms is at the base. And at harvest, it went perfect. So using all the methods, we had this diagnosis, the detection went up. Most of the vines that were positive we were getting positive results from all lamp, PCR, qPCR, and even the symptoms. 80% of those vines were showing symptoms at the base of the canopy. And middle was also good, but still apical on top of the canopy was iffy, but it definitely went up. And dormant cans is also good tissue samples. Using both lamp, PCR, qPCR, we are getting 100% detection from the dormant cans. Definitely there will be no symptoms when there is dormant stage. So really harvest and dormant cans were the time that we were detecting high percentage of positive from this. So taking all together, if you are sending for testing, waiting until either harvest or dormant and getting the base of the canopy just to avoid any false results, the base of the canopy. And these two time periods seems to be the optimum or the best for all kinds of tests. So when we talk about the detection, not only the positive vines, right? So we also do not want to test the vines that are negative, but the test results comes out positive. So we do not want false positives either. So if there is false positive, we might be just tearing the vine that were not infected and losing vines. So it is important that we also test for all the test efficacy on correctly identifying the negative vines as well. So we tested on the confirmed 20 negative vines and using the same methods. So during fruit set, all were negative, and except for lamp. For some reason, lamp was giving us false positive, 25%, more than 25% of the times it was giving us false positive. Yeah, we are still working on, like why LAMP is not giving us that many false positive at the earlier stages. Probably, yeah, there are some metabolites that might have interacted with the substance that are used for the LAMP detection. So we still have to fine tune if we're to use at these early stages. But if we waited for either Verizon harvest time, then chances of like correctly identifying the negative vines seem to be higher. And yeah, on dormant cans also we were kind of finding a lot of false positive. And yeah, the reason we thought there were many false positive in the dormant cans was due to the contamination issues. Okay, so let's think of it as so when we are taking the petiole samples, when in all these earlier stages, we're using petiole samples, the leaf blades, okay? So those are individually taken samples, right? So you remove the petiole from the vines, you put in a Ziploc, and that is separated. But when we are using dormant cans, we're using the same clipper. So maybe from like clippers to clipper, using the same clipper without sanitizing, it might have contaminated the samples. So we were getting false positive. That was one possibility that we could think of. And the other was, yeah, during the first year, we were taking the dormant cans during it was raining, like, yeah, Pacific Northwest, we get rain during the winter months, and maybe that. So we don't know exactly what happened, but we were finding lots of false positives on dormant cans when we tested during that time. So coming to the virus concentration, we also look at how the virus concentration changed over time. And so at fruit state, it seems like from base of the canopy, the virus titer is already there. So that's why we are seeing less false results from the basal samples. So this line for basal samples, this line for the middle samples, this line for the apical samples. And the higher the bar, higher concentration of the virus we're finding on those tissues. And yeah, this all represents the different times. So in both years, we're finding that the basal started with high, and then it went up during Verizon, and then it kind of slowed down. And same thing happened with all kinds of tissues. So the highest was during Verizon, and but at harvest and dormant, really there were not a lot of differences between the samples. So the chances of variability while taking the samples is less during harvest and dormant cans. So like no matter what kind of samples you take, probably you will be choosing the samples that has virus in it. So the variability was really less during this time. So that again, like another reason why we want to stay during this phase for sample collection. So summarizing these results, detectability of the virus by various methods depend on tissue type and vine phenology. So it also depends on what your goals are. So if earlier detections are desired, more sensitive methods such as PCR diagnosis should be used while using basal tissue samples. Symptoms-based diagnosis is also reliable during harvest. That is probably the least expensive method of diagnosing. At least 90% of the infected vines showed symptoms at older leaves at the base of the canopy. But you just have to trust your talent on identifying the symptoms. If you are confident enough to identify, we can rely on the symptoms to identify the disease. And LAMP is a second least expensive, and it's reliable during harvest and dormant can. And also, again, basal and middle canopy samples are fine if you're using LAMP. So yeah, let's move on to another project that we have been doing, and it is mostly towards the management aspect. So we also wanted to see if a vine is positive in a vineyard, how long it takes for like the entire vineyard to show the symptoms. So we looked at different, I think 8 vineyards in Southern Oregon, and we looked them for almost 4 years, just looking at how the disease progressed over time in a vineyard that had infected vines. So this is kind of a summary of the vineyards that we surveyed. So these were all the vineyard sites that we surveyed for the symptoms. This study was based on symptoms data. So we surveyed like this many vines, and there was no way that we could have tested. So all these study was based on the symptoms mapping. So this is the age of the vineyard. These vineyards were planted at different years, and there were some new vineyards as well that was planted in 2017. And this was the year that we surveyed. Since these were already there, we had 3 years of data from these vineyards. And since these 2 vineyards were all removed because of the virus infection in 2020, we could not have 2020 data from those vineyards. And we looked into individual vines in all those vineyard and mapped for the symptoms. And we also had this data. So some of the vineyards, like even in 2017, they were very aggressive. They were monitoring, and immediately they saw the symptom, they were removing the vines. But some vineyards were like, okay, yeah, I don't think that's a big deal, so I'm just gonna leave the infected vine as is. And there were some vineyards that were not roguing at all too. And that's how the disease looked in 2020. So these are the 6 vineyards that we were able to map for the symptoms in 2020. So this is one of the vineyard blocks, and the disease incidence. So all these red means the infected or symptomatic vine. Greens mean asymptomatic vine, and all the black dots are the rogued vines. These vines were removed. Yeah, in this block in 2020, it was 30%. In this block, it was 2.8%, but you see this huge black corner here. That's because the whole vine, the whole rows were removed because it was infected. And this is 15, it was 59%. This is one of the vineyards. These 2 were the vineyards where no roguing was done, not at all. And it had 59% disease incidence. And one of the interesting interesting practice from this vineyard was like, this was planted in, I think, this was planted in 2010, and then it was planted with a wider distance. So sometimes in 2014, I think, the vineyard owner decided, okay, so this is very wide, so let's put new vines, new rows inside. So all these you see are the new rows inside the old. The longer ones are the older rows, the shorter ones are the newer rows. And then, yeah, this part was left, and then they planted this part in 2017. So, like 3 different years of planting in the same vineyard, but, like with a very infected rows, they were adding new rows in between. And in a matter of 3 years, all the new rows were infected. And in 2020, you see this, the new vines that we were only finding 1 or 2% of these vines infected in 2020. And these 3 are the vineyard blocks that was planted in 2017. And when we were surveying these vines in 2020, there were already symptomatic vines in 3 years. So all these red dots here, they were symptomatic. But, like the incidence was below or around 1% on those, but they were still there. So we wanted to see, like how the roguing practice had made difference in those vineyards. So the blocks that were planted in 2017, the newly planted blocks, we wanted to see if roguing of those vines would make any difference. So in 2020, 7 out of 80 vines were infected. So when I say infected, that means they were tested, okay? All these blocks you see, so we were testing 11 vines. In this box here. So red means that was positive and green means that was negative in 2020. And also our other objective was, like when we rogue vines, there was always a question of how many vines do I go beyond the infected vine? Do I need to rogue those vines as well? So we didn't know that. So we just thought, okay, yeah, let's see 5 vines north, 5 vines south of the infected vine, and what would be the status of that vine. So we tested them in these boxes. And in 2020, the symptoms of the entire block was 1.3%. So in 2021, we went back again. We did the same thing. We mapped every single vine and then we tested. So you see the vines here in 2020, they are not there anymore because they were removed. This vine that was removed. This was removed, but they missed that one. Accident happens. But in most of the time, the infected vines were removed. And in 2021, we see new vines testing positive, but it was not the immediate next to the infected vine. So when you test, it's very difficult to judge, but probably the best practice is you do not have to worry about the nearby vines. It might eventually get infected, but you do not have to worry about going beyond the infection or the positive vines. Just removing that, the infection went down to 7%, and also the total symptomatic vines in the entire vineyard dropped to 1.2%. And in 2022, again, we did the same thing. The only 2 out of the 67 vines were positive in 2022 by removing all the infected vines. And the symptomatic vines, it dropped down to 0.7% in 2022. So this vineyard was actively roguing based on the symptoms as well as the infection data. And we also have another example here, which did not rogue vine. So this block, we are doing the same thing from the surrounding vines of the positive we are testing. And in 2020, from the test, 12 out of 110 vines were infected. And because they were not removing any of the infected vines in 2021, 41 out of 110 vines got infected. So jumped from 11% to 30% just in a matter of 1 year. And the disease incidence, this was one of the vineyards that we were mapping from 2017. And when in 2017, when we first started mapping for the symptoms, the disease incidence was just 0.5% in that block, and now it is 30%. So yeah, it's if it is left in the vineyard, it really goes bad in a matter of a few years. So summarizing this result, red blotch disease is definitely present in Southern Oregon vineyards, and without doing any active management, it progresses by more than 30-fold. And in areas where vines are aggressively rogued, the disease progression was limited to less than 10%. And roguing of adjacent asymptomatic vines are not necessary to limit the GRVB spread, but we have to regularly monitor for symptoms. That doesn't mean that it won't come back. It may come back, could be because of, like the latency of the virus that maybe we could not detect in the earlier year because the virus load was very low in that vine, or it could be the infection after the test. Like I said, if there are vectors, then that might have been infected after the test. So it is very important that we regularly monitor for symptoms. And also not just the block, the surrounding cultivars, the vegetation, and the potential vector can also play significant roles in disease epidemics. So this should be considered if the rate of disease spread remains high despite regular scouting and roguing efforts. So like in the earlier vineyard, even though they were roguing, so there were still some new vines popping up. So that could be because of the vector present in the vineyard, and also could be the source from what do you have outside of the vineyard. So we did this test of the surrounding vegetation. I do not have that data here, but we tested wild grape cultivars and also blackberries, because those were reported to be tested for virus from California. So we thought, okay, so we have a lot of blackberry bushes surrounding vineyards in Southern Oregon. We also have a lot of wild grapes surrounding vineyards in Southern Oregon. So in I think 4 of these vineyards that we were serving for diseases, we also tested on wild grapes and the blackberries. Wild grapes up to 70%, we were testing 10 vines in each. 70% of those wild grapes were testing positive for virus, but luckily none of the blackberry bushes were testing positive. So there is a possibility that, you know, if you have any grape related cultivar surrounding vineyard, it would be a good practice to keep eye on them as well. And yeah, we also have found that, you know, because red speaks loud, right? So on the red fruited cultivars, it's very obvious that, okay, red blots, and then you are very cautious about that, you test them, but often white fruited gets left behind. So that could be a source of infection as well. So even though the symptoms on the white fruited could be challenging, it's a good practice that we keep a good eye on the white fruited cultivars as well. So since vector plays a big role on spreading if a virus has established in a vineyard, I just thought I would put this slide as well. So this is 3-corner alfalfa hopper. It's very tiny creature, it's very cute, but yeah, it does do the damage. And one of the ways to find out if there is a vector activity in the vineyard is look for these flagged vines. So when vector, when this hopper feeds on the shoots, it leaves that redness on the top of the shoot. So it does not necessarily mean that you have a virus, because this vector has to be able to take the virus from the infected plant and transmit to there. But you know, this is just for the practice. If you see flagged vines like this in a vineyard, there are chances that you may have a potential vector in the vineyard. And if you have an infected vine, then probably the spread will be faster in that. And yeah, just looking, I don't know if you can see it, but there is like a constriction at the leaf petiole or the shoots. Yeah, this kind of symptoms indicate that there is a vector activity. Yeah, I think that's all I have. Thank you very much for being here today. And yeah, I think we are open to questions. I managed to put this, Charlotte, my contact information. Okay, so if you have any questions regarding any of the slides or anything regarding red blotch, please feel free to reach out. That's my email address and phone number. Yeah, and I think we are open to questions.
Yeah. So no questions came through the chat box, but I will wait and see if anyone else has some questions, because I got a few quickies. Any questions, guys?
Do we know whether we have the most likely vector in Colorado?
Oh, no. That's a summer project for me.
Yeah. No, there's some growers that think we don't have the 3-cornered alfalfa hopper. But that would definitely be something to check out. And trying to better understand the symptoms of the vine that have been attacked by the vector. When you say you called it a flag,
yes,
and so I see the leaves are a little different color and then it's kind of bent. Is that kind of the symptom or?
So bent, not necessarily, but mostly like the redness just sticks out. So you
Okay.
have all green, if it is a red fruited cultivar, okay? So if it is all green, then just one leaf or the one shoot just sticks out, and that is turning red.
Okay.
Yeah, and the vector girdles, and the redness is because of the girdling that you would see on the leaf petiole or on the shoot. So that kind of the girdle is the indication of the vector activity.
Okay. And is it a particular time during the season towards the end or?
Towards the end, I would say starting from Verizon to the harvest. Yeah. It seems like when berries start to turn color, the leaves also start to turn color. So yeah, if you see symptoms of the vector activity, probably that will be the time that you will see those symptoms.
All right. Well, thank you.
So I have a quick question for you. Have you guys run into any issues with saltburn? The white varieties, the way you were describing the symptoms, look really similar to saltburn. So that might just be another confounding one to throw in there for you.
Did you say sulfur or sunburn?
Saltburn. We have very alkaline, salty soils here.
Okay.
Yeah.
Oregon gets washed out.
Yes, yeah. Yeah, I do not know. Because yeah, I haven't seen saltburn symptoms. So it's difficult for me to probably it's good to compare, like the differences if it's saltburn or the virus, Okay, yeah, that's another confusion to the list of the symptoms, definitely. Yeah.
Well, does anyone else have any other questions? If not, then I will give you 5 minutes back to your day. Thank you so much for showing up and staying until the end. I really appreciated it. I know I certainly learned a lot and hopefully won't be bugging her too much with questions later on, but thank you guys so much. And Atala, can you stay on and I'll debrief with you real quick?
Sure.